Across the world, billions of devices are coming online. Sensors, drones, autonomous machines. But as these systems grow more independent, one question becomes critical. Who do we trust? Today, most trust lives in centralized systems, platforms, institutions. But the closer technology gets to the real world, the more dangerous that becomes. So what happens when trust itself needs to move to the edge?
Most blockchains are pretty big. Most blockchains require a lot of memory and a lot of power, when you think of the other, massive players out there. Whereas Minima's real trick is that it is so tiny. Every single user doesn't run a light client, they don't run a wallet, they run the whole thing. And again, this helps with security, because security is the same as decentralization. The more decentralized your system is, the more secure your system is, because when we refer to the security of a blockchain, what we're really referring to is its ability to resist censorship attacks.
Most blockchains were never designed to live inside machines. To solve that problem, Minima partnered with the University of Southampton, alongside two of the most influential technology companies in the world, Siemens and Arm.
So this project is called a group design project, which we've collaborated with students at Southampton University. But the industrial partners are Siemens and Arm. Siemens is one of the world's largest provider of industrial machines, devices, hardware and software. And of course, Arm is the world's largest provider of IP for chip design. So it's very significant that Siemens and Arm are working together, and they will have reach across the globe in terms of IoT and autonomous devices.
This partnership bridges research, silicon design, and real-world deployment, creating a testbed for something no one has ever done before.
So the way I see how Minima shapes future autonomous systems is that it provides a very low power and sustainable way for decentralization to happen. So in a decentralized system, having a very, very lightweight protocol like Minima actually helps out. And with our project, running Minima on a dedicated chip optimizes that even further, making the whole system more efficient and more secure.
That's the challenge Minima brought to Southampton. Minima was designed differently from the start, not to scale upward, but to scale outward.
Minima is what's known as it's a compact blockchain, which means it's very, very small and it fits on very low power devices. But to be able to do it on today's hardware, I think Minima stands alone to be able to do that.
This project isn't about shrinking blockchain, it's about rebuilding it at the silicon level.
We chose to do the project on the drone this time because drone is quite a challenging environment, right? You've got the signal fluctuations, you've got different signal to noise ratios you have to worry about. And we've proven that Minima can run alongside the drone's current operating system, right? And still work as a dedicated subsystem within the drone. If you can run this on a drone, then technically you could run it anywhere.
And what they achieved has not been done before.
This is a world first. This is the first time that blockchain has been embedded into hardware that has then been used in autonomous vehicles. And Minima is the only blockchain that is compact enough to run in small devices, low power and low energy devices. This is the first demonstration where blockchain can really scale.
Trust lives inside the device itself.
So obviously today we've been looking specifically at a use case related to a medical drone delivery. But what it actually demonstrates is a much broader set of use cases. With Minima being as small as it is and operating at a chip level, it's capable of working at very austere conditions, and that could be multi-domain, whether it's land, sea, air or space even, and that opens up a whole world of potential use cases.
This isn't about drones. It's about building machines that can be trusted with real-world responsibility. But theory only matters if it works in the real world.
The entire demonstration showed sensor data from a live drone being recorded on the blockchain, verified by a controller, and the controller then issuing the certificate to fly. The drone then took off with its package. The sensors were being recorded the entire flight, and then when it landed, the drone sent back the certificate to fly. The reason this is so important is because in delivery of important cargo, the flight path and sensors of the drone need to be recorded, and our technology has shown that this can be done entirely autonomously and independently verified by a third party.
The test flight was 100% success. And what I mean by that is that we managed to actually take off and fly around and still be connected to the Minima network.
Not a simulation, not a lab demo, a live blockchain node running autonomously inside a flying machine. Minima isn't waiting for the future of decentralized infrastructure, they're building it in silicon.
I think having such systems is very important because I think someday in the future, this could be a regulatory requirement. So any sort of system that's decentralized, it needs to have a secure chip like what we're building today in order for it to be trusted. I think one of the differentiating factor of Minima is that everyone is running everything. It is sort of like a blockchain that could be pervasive in the environment. To the blockchain community and to the connected world as a whole, I think Minima provides a whole new layer of security which wouldn't be there before.